Hello everyone, thanks for being here at this Sylius conference in Lyon, my hometown, so thanks for being here. So this is the morning, we all need coffee, so let's start, smoothly, calmly. So today we're going to talk about laundry, not code. I'm lying, but we're going to talk a bit about laundry first. And we will see how to never run out of clean socks. So who here has already done a laundry? Raise your hand. Okay, some of you, okay. For some of you, it's going to be new, so we're going to explain it together, okay? So it all starts simple. I mean, you have dirty clothes, and so you put the clothes in the machine. So far, so good, right? And then the machine does its job, and the clothes come clean. So step 2, take them out and put them in the basket so we can hang them. But step 3, the drying rack, aka the laundry demon. I mean, at the first sight, it looks harmless. But the moment you give it laundry, it reveals its true nature. And its nature is spreading chaos, right? I mean, we all have a drying rack at home full of dry clothes that we just move around. And we walk around, and we take some clothes from, and we put some other clothes back on. We all have that, I'm sure. And I have one waiting for me in Lyon right now. So, step 4, there are dirty clothes again. Maybe the clothes we took from the drying rack, So you start another load. Step 5, you take out the laundry once again, and you put it in the basket, heading to the drying rack. But part of the previous load is still here. I mean, so step 6, you put the new laundry on top of the previous laundry, and everything starts mixing up together. Wet clothes make the dry clothes damp, and there is no more space, so clothes fall on the floor, and it turns into chaos, real chaos. You know that? Yeah. So, the result of all this, you are completely overwhelmed by the laundry. You thought everything was under control, but now it's impossible to tell what's clean and what is freshly washed. Except by touching it, but everything is a bit damp now. And each new load makes it worse. So, if you are wondering who is that person, honestly, that's me most of the time. So, let me introduce myself. So, my name is Mathias Arlaud. I should have been here under the arrows, but I can't move, so imagine me right there. So, my name is Mathias Arlaud. I'm not great at managing laundry. As you might have heard, I'm a French PHP developer from Lyon. And I'm a part of the Symfony Core Team. I contribute a lot to PHP, API platform, and Symfony ecosystem, and a bit of Sylius as well. And I co-founded the baksla.sh company with Robin Chalas, which is another Symfony Core Team member. And we do consulting, architecture study, audit, plenty of stuff about Symfony and API platform. So if you ever need help, feel free to reach me out. I would love to help you. Okay, so take a look at this image, a close look. This should remind you something. This maybe can remind you your own log right now. When you do server start, you open your log, and it should be full of this kind of stuff. But it can also remind you the drying rack we have seen earlier, because yes, this is a great metaphor. Yes, because indeed, the deprecation in your code follow the very same pattern. They accumulate little by little. It starts under control, but you quickly get overwhelmed by all of that. And just like the laundry, if you do not deal with them regularly, the chaos arrives very fast. So my goal of today is to show you how to anticipate, organize, and manage the chaos of deprecation in Symfony and Sylius applications. And if you follow the principles I'm going to teach you, I hope that your code will stay clean and already up to date, and you will never feel a new version upgrade again. So in short, I'm going to teach you to become a laundry and deprecation hero. Okay? You're still sleeping, so let's start with a little quiz to wake you up. So raise your hand to answer. According to you, what is a deprecation? Who thinks that a deprecation is a bug? Okay. Who think that a deprecation is a feature? Okay. Who think that a deprecation is an option? And who think, it's for my French audience right here, that the deprecation is D, la réponse D. Was sure about that. It's not la réponse D. A deprecation is often linked to the arrival of a brand new feature. And for example, in Symfony, we do categorize contributions, okay? We have minor contribution, bug contribution, fixing bug contribution, and feature contribution. And indeed, when a user add a deprecation into the Symfony framework, we categorize this as a feature. So, a deprecation is a feature, but that's not all. It's also a letter sent by maintainers of Sylius, Symfony, or whatever, to users, to developers, saying, okay, dear Sylius developer, we won't break anything right away, but we give you advance notice, so you have time to migrate gradually. And that's exactly the point of a deprecation. The goal of a deprecation is to give you a clear and an early signal that you have to make your code evolve, so that the framework code can evolve too in a second time. And don't worry, I'm going to explain it a bit more later. And just like the drying rack, we don't want you to be overwhelmed. So we warn you that a new load is coming, so you have time to organize your laundry, your code. Yeah, you understood. So yeah, so why do we deprecate stuff? It's something constraining for either framework maintainers and framework users. So why do we do that? So here is, for example, the old way to represent types within Symfony. And we used to use the property info component of Symfony, okay? And for example, if you want to represent an integer, you will have to provide an array with a single type inside, which is of type int. If you want to represent a list of Boolean, you will have to provide an array with a single type inside of type array, that is a collection, with the key type, which is an int, with a value type, which is a Boolean. And for unions and intersection, you will have to provide an array, but with several types inside. So while it works, it's kind of heavy, and kind of verbose. And moreover, some stuff are even impossible. If you have a close look at the union and the intersection, you will see that they are exactly the same. So it's impossible to make the difference between an union type and an intersection type. And this is logical because the property info component appeared before the introduction of the intersection type. And that's why in Symfony we decided to introduce a brand new component, which is the type info component. And as a result, when you want to create an integer, you call the method int. The list of Boolean, you call the method list, and you provide a Boolean inside. And you have now a method to create union and intersection types. So as you can see, it's way cleaner, less verbose, and it supports the difference between union and intersection. And in that context, the goal of the deprecation is to ask you to update your code that is using property info so that it uses type info instead. Okay? Okay, so how does a deprecation show up in a Symfony and Sylius application? First, you might know, you might have plenty of that into your log. It's a log. And the log is an explicit signal that something in your code has to change, okay? And the message is explicit. Here, we are telling you that the type of the property info component class is deprecated and you have to use the type class of the type info component instead. And this is exactly these logs that accumulate if you don't handle them carefully, okay? Like the drying rack. And if you use the profiler of Symfony, and I recommend you to do so, you can see directly the list of deprecation in the profiler, okay? And this makes it easy to spot which part of your code is affected because you have the little button show trace that shows you where the deprecation has started. Okay, So now that we have seen how deprecation appear in your application, so in log and in the profiler, easy so far, you might ask yourself, because you are a developer and you are curious, I hope so, so you might ask yourself concretely, what is a deprecation in terms of code? I mean, how does Symfony and Sylius actually do it to provide us some nice messages? So let's have a look under the hood and open the vendor folder. So if you open the vendor folder, you're going to find this. So here is the type class of the property info component, and as you can see, we have a function trigger deprecation with the name of the package and the version the deprecation has been introduced in, and an interesting message. And this is literally the starting point of deprecation. And every time your code execution passes through here, Symfony, for example, sends a signal, warning, this piece of code won't live like that forever. And what does trigger deprecation do? Actually, it does not do that much. It's mostly a nice wrapper around the trigger error native PHP function with the e-user deprecated level. Okay? Not that much. And then it's like Symfony or Sylius gives birth to a little creature, the deprecation. And this little creature doesn't stay hidden. It starts climbing step by step, following the call stack, right? And it's rising up through your application. And when it reaches the top of the call stack, it's caught by the error handler. You can see the error handler as the guardian of deprecation. It does much more stuff, but in terms of deprecation, the error handler does that. And indeed, it intercepts this little creature, preventing to get them lost, or they disappear, or they preventing to let them break everything in your application. So technically, the error handler is pretty simple. I simplified it because it's really complicated, but if you read that, it's simple. So technically, it registers a custom error handler using the setErrorHandler native PHP function, which is used to define how to behave when we have an error in PHP. Okay? It's kind of deep, but Symfony does stuff for us. Okay. And so the error handler intercepts the e-user deprecated errors and convert them into a really meaningful exception, silenced error context. That doesn't make sense, but anyway. And then it logs them properly into a deprecation logger so that they can be used everywhere. And it put the exception in the context so that we can retrieve it later on. So in short, it transforms and centralizes the trigger error into something understandable and usable. Okay. So now that we know how a deprecation is born and lives, it's time to see how to make it disappear. This is why we are here right now. To do so, we're going to read the upgrade.md files. Indeed, for each version, Symfony and Sylius provide an upgrade.md file. Within you can find a list of what has been deprecated and what to do, what to use instead, and often with a before and after example. So you can see upgrade.md file as official migration guide for deprecations. And here, as an example, we can see that the exclamation mark tagged has been deprecated, and that should be replaced with an exclamation mark tagged iterator in the YAML files. So, all right, let's go. Let's follow the upgrade.md file, and change the exclamation mark tagged by exclamation mark tagged iterator. And then you have it. No more little creature in your application. So unless you are doing an Hello World application in time to grow, there is never just one deprecation, right? In a real application, you have plenty more deprecations. So now we're going to see how to isolate, to collect, and to fix them in an organized way. So first step, isolate these little creatures. And to do so, we're going to redirect the deprecation logs into a dedicated file. And in that way, that they won't get mixed, with everything else. I mean, they won't get mixed with your application logs. And they will be in their own files, so you know exactly what still needs to be fixed. With monologue, it's kind of easy to do so. Indeed, as we have seen earlier, the error handler puts the logs in using a deprecation logger. So we have a channel deprecation, and then we can adapt our handlers. So for example, let's say I have a main handler, and now I can say in my channels, I want everything except my deprecations. So my main logs won't be polluted anymore with the deprecations, okay? But we just don't want to silence them. So we create a new handler, a deprecation handler, that only takes the deprecation channel and log into a dedicated file. For instance, a deprecations.log file. Okay? Step 1, isolate. And then, step 2, we rely on the upgrade.md files and apply all the required changes. Okay? So this can be plenty of work and can be tedious, but I can promise that we design the changes so that they are as simple as possible for you. But sometimes, yeah, you have a bit of work to do. But okay, you do that, you apply the required changes. And finally, thanks to the hard work, we go from this to that. Congrats, you can now invite your friends at home once again because you do not have anymore a drying rack in the middle of your living room. So that's nice. Okay, so once you start fixing deprecations, how to make sure that you do not have forgotten one, and how to make sure that you have handled all of them. To do so, you just have to interact with your application, to click everywhere, to execute every function, even the deepest one, logged as an administrator, as a user, not logged, and so on. You have to run all the feature and all the stuff in your application. And then you just have to check with our trick if there is any deprecation into the dedicated log file. For example, you can run this command that counts the number of line of deprecation and assume that there is none. After writing it, there is much more simpler way to do so, but anyway, it's one way of doing. You just check that the deprecation file is empty, and that means you don't have any deprecation if you interact with all your app. But testing manually is really tiring. And it's not reliable. I mean, let's say it's Friday evening. You have to test the application. You want to get home. So you take shortcuts, you go fast, and you say, yeah, this feature is okay, you know. So yeah, it's not reliable. We are human and we are lazy. So yeah, it's tiring. Okay. Hopefully we are in 2025, and in 2025 we have an obvious solution, which is letting a robot do it for us. And these robots are the PHP unit and its sidekick, the PHP unit bridge. Okay, tough question. I imagine and I hope that everyone in this room is testing automatically their application, right? Who still is not testing? Oh. Okay. Normally I make fun of people that raise their hand right now, saying that if they are tired raising their hand, just, yeah, test your app. Anyway, for those who don't know the PHP unit bridge, it's basically a Symfony package that enhances PHP unit, okay? So it adds feature for clock, for DNS, for anything. And one of the things is it enhances PHP unit about deprecations. And that's why the deprecation, that's why the PHP unit bridge comes with its own deprecation error handler. That, same as the error handler, intercepts and stores deprecation during tests, okay? And in that way, you can configure the test execution with an environment variable, which is Symfony deprecation helper. So the test automatically fails if there are any deprecation, okay? And this way, you immediately know and automatically know if there is something to fix before moving to the next version, right? So you can pass more options to this environment variable, and this configuration allows a very fine-grained control over deprecations. So we have three main kinds of deprecation. okay? We have the direct deprecation, which is the main one. I mean, yeah, it's something that is triggered by your code, okay? We have the self-deprecation, which are either triggered and created by your code. Let's say somewhere in your application you have written yourself trigger underscore deprecation, and elsewhere in your app you raise that deprecation. These are self-deprecations. And finally, you have indirect deprecations, which are deprecation generated by your vendor, your dependencies. And I think there are plenty, there used to be plenty in Sylius. Anyway, so you can assign them an integer, and the integer is kind of, you know, the size of the laundry basket, is how much deprecation I allow. And you can mix them up. You can say, I want no self-deprecation, but I authorize myself 10 direct, and let's say 100 indirect. And this granularity is great because it lets you, you know, prioritize what to fix first and, yeah, adapt it to your business and to your project. But since recently, PHP units natively handle deprecations now. So the PHP unit bridge is kind of, you know, self-deprecated. And to do so, you just have to run this simple command, vendor bin PHP unit -- fail on deprecation. However, as far as I know, you lose that fine-grained control with the direct, indirect, and self-control. So yeah, but this feature is still quite new, so it's worth keeping an eye on it to see if it can be improved, and I'm sure it's going to be improved that way. Okay, so final step. I hope you all have a continuous integration, and so you can automate it in a CI. Indeed, we can create a job, okay, a deprecation-free test job that, for example, block merges if there are any deprecation. But this is kind of hard, you know. So you can be smarter and even create a job that if there are deprecation, it, I don't know, call a webhook and create a ticket on Jira or whatever, you know. But you don't let deprecation just go like that. You cache them and do something with them. And this is really important to have, you know, a sane deprecation handling. And yeah, with that, your deprecation gonna stay under control. Okay. Just as a side note, it's important to understand that deprecation are triggered at the runtime. Okay. This means that the deprecation is created and thus detectable only when the trigger deprecation is actually called. Okay. And this is why automated tests and CI are really crucial. We need to call that line. However, it's hard, you know, to achieve 100% code coverage, and it's hard to be certain to, yeah, that everything has been properly tested, even for big applications such as Sylius e-commerce applications, of course. And while preparing this talk, an idea came up to me. What if we could detect deprecations, but without even running the code? It could be great, right? And yeah, indeed, we could create a PHP stand extension that checks if the trigger deprecation can be called by your code statically. And this would allow us to detect some deprecation even before running the code. And this would complement the strategy, the classic strategy based on logs and tests. Alors, well, yeah, always do that. Yeah, that's not that easy. Otherwise, I would have announced the creation of that extension with a great fanfare. But no, it's a bit more complicated than that. But still, I'm working on that. And if this idea inspires you, feel free to reach me out and we can, you know, work together on that extension so that, yeah, to make it appear. Okay. Next part. Strategy. Yeah, so how to organize things so that managing deprecation never becomes a nightmare like the drain rack. So we're going to talk about strategy and development cycle. So you might know, and you must know, that the core of Symfony rests on two pillars. which are the semantic versioning and the backward compatibility promise. So the semantic versioning defines when a dependency might break your code depending on the version, okay? And the backward compatibility promise defines how minor version remains compatible with each other and with your code. So if you did not understand one word of what I said, and you are a developer, otherwise it will be complicated, don't worry, we're going to go into the details right now. But great news, since recently, Sylius decided to follow the very same principles. This means that every benefit that we're going to see later going to be applicable for Symfony and Sylius application. So I think that's a great step made by the Sylius community. So let's take a concrete example for the semantic versioning. We have the version 2.1.6 of Sylius. And each number here has a very precise role. So in this, let's say that we have an X, Y, Z that represents major version, minor version, and patch version. So the patch version, that means that if you go from 2.1.6 to 2.1.7, the new code that you're going to pull will only contain bug fixes, okay? It will just be like that. We have seen some bugs, we fix them, and then, yeah, the new code will only contain bug fixes. The Y is for minor. And if you go from 2.1 to 2.2, for example, you're going to get new features, okay? But that does not break the compatibility with your code. If your code works with the 2.1 version, it's going to work, hope so, with the 2.2 version of Sylius. And this is the main difference between the major version and the minor version. A major version, when you get the new code, if you go from 2 to 3, yeah, if your code works with the version 2 of Sylius, it is not guaranteed that it's going to work with the 3 version of Sylius. Even more if you have deprecations. And yeah, if you have deprecation. If you have not, it will work. And we're going to talk about it a bit later. Indeed, the semantic versioning is combined with the backward compatibility promise, which explains how to use Sylius, the Sylius code, so that it does not break when you upgrade from a minor version to another minor version. And the Sylius BC promise inherits from the Symfony BC promise. And the Symfony BC promise could not be clearer. I mean, you can see in the doc that if you are using Symfony classes and you create a new instance, you extend the class, or you access a public property of that class, yeah, if you go from one minor version to another, your code will work. Pinky promise. But if you are doing some dark magic and access a private property using the reflection, we cannot promise that. I mean, private is private. We do what we want in our classes. So yeah, your code might not continue to work from one minor version to one other minor version. So I strongly encourage you to read this documentation. It's extremely important because you're going to know if you can upgrade safely from one minor to another minor. And plus, Sylius had some extra rules really dedicated to the Sylius context. You can find it in the Sylius documentation. And yeah, it has additional rules to the Symfony backward compatibility promise. For example, some methods can be added to the model interfaces while it's forbidden by the Symfony BC promise. So yeah, take time to read these two documentations. They are really interesting and are important when you use a framework such as Sylius and Symfony. Okay, and the BC promise includes something else, which is the continuous upgrade path. And the continuous upgrade path is the strategy adopted by Symfony and Sylius to allow smooth version upgrades. Basically, it's better to have a sign saying exit in 500 meters than a sign saying exit now. Yeah, it's already too late, normally. So Symfony and Sylius follow one rule. Nothing have to change without being announced. Okay? So let me share a true story to illustrate that. So once upon a time in Symfony 6.1, you'll see that this story illustrates the challenges of the backward compatibility promise and continuous upgrade path in the real life. So once upon a time, at that time, in Symfony 6.1, I decided to introduce the serializer profiling feature in Symfony. And to make this feature work, I needed to introspect the normalizers. Normalizers are, for the one who does not know, are a bit, a tiny part of the serializer. And as I assumed that everyone was injecting the normalizer interface as recommended by the object-oriented programmation principles, because we always need to use the highest level abstraction. So I was sure everyone in the world was injecting the normalizer interface. And this was nice for me because I could have replaced the normalizer with a traceable normalizer, which is a decorator that implements himself the normalizer interface, but contain your normalizer and collect information before and after to see how much time it has taken and so on and so on. But after the release, problem. I received direct messages from Fabien Potentier and Nicolas Grécas saying me, coucou, comment ça va? Everything is broken. Ah, okay. The kind of direct message you don't want to receive early in the morning. But still, I got one. And when trying to understand with Nicolas and Fabien, Nicolas said at one time, and it's, stuck into my mind, Nicolas said, it's a jungle out there. And yeah, he was right. Indeed, developers use the framework in all possible ways, even the most unexpected, because they are allowed to do so, So you need to anticipate everything, and even the weirdest behaviors. Specifically, when developers explicitly needed the object normalizer, instead of injecting the interface and wiring properly the object normalizer, they were directly injecting the object normalizer, relying on the auto-wiring. And I'm sure it sounds familiar to some of you here. Plenty of projects was doing so. I was not aware. But yeah. So then when I replaced the object normalizer with the traceable normalizer, boom, type error. I want an object normalizer, I get a traceable normalizer. It doesn't work. So Symfony 6.1 is broken. It's really hot in there. I need to react, and we need to react really quickly. And to fix the problem in 6.1, we decided to create a feature flag, collect serializer data. And by default, the value was false, so that the feature was disabled for everyone by default. And the replacement of the normalizer by the traceable normalizer was disabled by default for everyone. Problem solved. In the same time, we also documented that if you have, you can set it to true if your code is compatible. If you only inject normalizer interfaces, you can enable that and leverage the serializer profiling. And we also updated the recipes so that the flag is true in the configuration. The recipes are creating brand new files when you create a project, okay, the YML file you see. And so we set the flag to true inside so that the new project starts on the right track directly. And then we have let some time pass, quite a lot of time. To be honest, we have forgotten this feature, that feature. That's why so much time went away. But still, this gave developers time to upgrade gradually their code. And finally, in 7.3, so not that long time ago, we have decided to finally deprecate the fact of setting that flag to false. And this will force developers to fix their dependency injection. I mean, going from the right, with the wrong dependency injection and the flag to false, they will be forced to set the flag to true, and then their project will be broken, so they're going to need to fix their dependency injection before moving to the 8.0 version. And so, starting from 8.0, we're going to be sure that the flag is true and the dependency injection are correct. Then in 8.1, we're going to be able to deprecate the whole flag itself, because it's going to be true for all people. And then in 9.0, the flag can finally be removed and the project and their injection will work as expected. So thanks to that, backward compatibility promise and continuous upgrade path, no project was broken except during a tiny bit of time. Sorry about that. But yeah, thanks to that, no projects were broken. But if you make a quick calculation, and forget that I have forgotten this feature, the upgrade have taken 5.5 years. So yeah, sometimes changing a feature in Symfony takes a long time, but it's necessary to make your usage as smooth as possible. Okay, end of the story. So you should know that Sylius releases 2 to 4 minor versions per year and 1 major version every 2 years. So you can anticipate and prepare yourself. And my best practice, one of the key takeaway here, is to fix deprecations as soon as they appear. And as a minor version is out, update the dependency. Update the dependency directly and fix right away deprecation. Integrate it into your development cycle. It's part of the technical debt, to be honest. And then when a new major version comes, nothing's left to do. I mean, you are already ready. Your code is already compatible. So if you manage deprecation continuously, you're going to avoid the stress and the chaos of a new major version. It's like paying taxes monthly instead of all at once. I mean, it's the same result, but it's way less painful. Okay, so we're going to move to the final part of that talk, and we're going to talk a bit more about code, because we love code, yeah. So we're going to inspect the engine and see how Symfony and Sylius handles the backward compatibility promise. The goal here is not to become a contributor, so I recommend you to become a contributor, it's great, really great, but it's rather to get an idea of how it works. And this way, you're going to learn technique that might be useful for you and for your projects, even more if you have projects with several, packages that are talking to each other. Alors, yeah, a major challenge for maintainers is to make the old code and the new code working at the same time, all while providing, a continuous migration path. So our maintainers are a bit like this pig, move slowly in balance between the new code and the old code, but without the heart. And yeah, it represents a large part of maintainers' work. For me, I can tell it's almost 60% of my work to, just deal with this backward compatibility promise, and that's. Okay, so let's take a look at 2 or 3 techniques used by Symfony and Sylius to handle that. So yeah, a side note, it's not necessarily exactly how Symfony and Sylius do, because sometimes they use more sophisticated mechanism, but we're going to simplify it to get the idea, and it's going to work. The code will work, yeah. Okay, so let's imagine that we want to remove an argument from a method, which means going from this in 7.2 to this in x.y, okay? So we go from int foo bool bar to int foo only. And the goal here is to make the code using foo and bar continue to work while preparing the future version with only foo. So how to do that? Who think he knows the technique to make it work with 2 and 1 argument at the same time?
Default value.
Default value, it's one part of the answer, and the other, right, is func num_args, for example. Okay, so we're going to use the following technique. We're going to make bar nullable and optional, okay? And we're going to count, using the func num_args function, how many arguments are given to the function, right? And if 2 arguments are passed, we're going to trigger a deprecation saying that passing bar is deprecated, it's going to be removed in 8.0. So we tell, do not pass bar anymore, otherwise it won't work. And finally, we're going to adapt the rest of the method so it no longer uses bar. And in 8.0, because everyone is only using foo, otherwise they will get deprecation, we can now apply what we have planned, which is remove bar. Simple, right? Okay, second example, let's say that we have made a big mistake and finally we want bar back. Which means going from this in 7.3 to that in x.y, okay? Having bar back. For that, we're going to take advantage of the fact that PHP doesn't mind if you pass two arguments to a method or a function that only needs one. He doesn't care. It's a bit weird, I can tell, but it's really, really useful here. Indeed, thanks to that, we're going to use the funcGetArgs function to get all the past arguments, even if they are not in the function signature. And yeah, in this way, we're going to be able to retrieve the second argument if it has been passed, or emit a deprecation if it has not been passed. And of course, we still need to add some PHP documentation to help static analysis and IDEs because, yeah, we are doing some dark magic here. But I like that. That's great. Anyway, in 8.0, we can modify finally the method signature because we are sure that all calls now pass two arguments. Otherwise, they will get a deprecation. Last but not least, let's say that we want to change a return type of a method. So in 7.3, do something returns an array. And let's say that we want in x.y that do something return a value object. You will see it will be a bit more long, a bit more complicated. To do so, we're going to create a new method, do something bis, with the correct return type. And we're going to deprecate do something in favor of do something bis. And we're going to move the logic from do something to do something bis to keep, the business logic as in only one place, of course. And then we can call do something bis from do something and store it in a result, for example, and convert the results back to an array, the value object back to an array. Okay. So now in 8.0, we have the great return type, but the method has the wrong name. So half of the way done. But yeah, we can remove do something because everyone is now using do something bis. So in 8.1, we can do the step back. We can reintroduce do something, but with the correct return type, deprecate do something bis in favor of do something, move back the logic from do something bis to do something, and call do something from do something bis. It's really hard to hear a lot of do something bis. Read the code, you understand. Still, in 9.0, nobody is using the second method, so we can finally remove it. Quite a bit of work. And it's quite a bit of work, but it's also very long. If we respect the Symfony release calendar, for example, here changing a method signature took 2 years and a half. So it's not something to take lightly. You don't change a return type like that. You need a very good reason. Okay, conclusion. So remember, deprecations aren't enemies, even if they are really annoying, but they are love letters sent by maintainers to help you improve your code. And yeah, if you manage deprecation properly, major upgrades and become really easy and safe. I mean, it's not that painful if you are, a laundry superhero. To do that, use the good tools for it. Use the logs, use the tests, use the CI, and maybe one day use PHP stan, we'll see. And yeah, integrate the deprecation management into your development cycle. And this is the most important takeaway. Allow time to handle deprecation. You will have to allow it at some point. So yeah, that's it. I'm done. Thank you very much. And if you have questions, see me, yeah, upstairs. I think we are a bit late. Thank you.